In this problem, Catherine deposits $100 into an account at the beginning of each 4-year period for 40 years. The account credits an annual interest rate of I, and the accumulated amount at the end of 40 years is X, which is 5 times the amount that had accumulated at the end of 20 years. They ask us to find X. We'll note first of all that the interest rate here is different in timing from the payment period. So the first thing we'll do is to convert our interest rate into a 4-year interest rate that we'll call J. The way to do this is to take 1 plus the annual rate of I, raise it to a 4-year period, and then subtract the principal of 1 off that answer. For the 20-year period, we have $100 payments. The first one is made to accumulate for a period of 20 years, which is 5 4-year periods at J. The second payment comes in and accumulates for 16 years, which is 4 4-year periods, and so on until our 5th and final payment accumulates for 4 years, so that we have an amount at the end of 20 years total. We'll use an actuarial symbol for this of S double dot, since we're talking about an annuity due with payments made at the beginning of a period. 100 times S double dot J for 5 years. For 40 years, we'll have an expression that's very similar. It's going for twice as long. So instead of 5 payments, we have a total of 10. We also had been told that the amount after 40 years is 5 times the amount that had existed after 20 years. So we can write that by setting these two expressions equal and then multiplying the 20-year amount by 5. From here, we'll expand the expressions for S double dot, first canceling out the 100s to simplify, and then remembering that the formula for S double dot 10 with an interest rate of J is equal to 1 plus J to the 10th minus 1, all divided by the equivalent discount rate of D. We'll see in a moment that that doesn't really matter. On the right side then, we'll expand similarly. S double dot 5 is 1 plus J to the 5th minus 1 divided by D. Then we see that we can cancel out the D's from each side of the equation. From here, we have 1 plus J to the 10th minus 1. And if we distribute that 5 on the right-hand side through the remaining parentheses, we'll have 5 times 1 plus J to the 5th minus 5. This is a quadratic equation, so we'll take the step of moving everything from the right side of the equation over to the left side, giving us 1 plus J to the 10th minus 5 times 1 plus J to the 5th plus 4 equals 0. To solve this, we'll do some algebraic substitution, letting x be equal to 1 plus J to the 5th. That'll make it slightly easier to work with this problem. The rewritten equation is x squared minus 5 times x plus 4 equals 0. We could do the quadratic formula on this, but in this case, this equation factors rather cleanly to x minus 4 times x minus 1. And we can ignore that x minus 1 because the result of that would end up giving us an interest rate of 0. So we turn our attention to x minus 4 being equal to 0. In other words, x being equal to 4. X we had defined as being equal to 1 plus J to the 5th, so this is equal to 4. We'll take the 5th root of both sides of the equation and have 1 plus J is equal to 1.31. Then subtract the 1 from both sides to give us a 4-year interest rate of J of 31.951%, just a little short of 32%. We now have everything we need to be able to calculate the amount X, which was the amount accumulated at the end of 40 years. We had already found an expression for this which was 100 times S double dot 10 with an interest rate of J. We'll expand that out fully into the formula as we had done before, as 1 plus J to the 10th minus 1 divided by D. Remember that D can be rewritten as J divided by 1 plus J. So in the algebra here, that means we can replace D with a J in the denominator and then multiplied by 1 plus J off to the right. Since we know what J is, the rest of this is very straightforward. We knew that 1 plus J to the 5th was 4, so 1 plus J to the 10th will be 4 squared, minus 1, and then divided by our 31.95% interest rate, multiplied by 1 plus J, which was the 1.31951, all leading to a final answer of $6,195.